homeowners, the idea of renovating is a daunting prospect. Building renovations have long been associated with stress, delays, and spiraling costs. Such possibilities are among the reasons why the renovation rate across Europe is so low. Less than 1% of new buildings are refurbished every year. Right now, 3/4 of EU building stock is energy inefficient, meaning there is a huge potential of improving the building quality with direct consequence on enhancement of indoor environment and reduction of not renewable energy consumption. For all these reasons, the EU-funded project FORARenew has focused on transforming the renovation process to make residential refurbishments cheaper and easier. This is achieved through a structured FORARenew cost-effective deep renovation approach, supporting all people involved in the decision process and made of building auditing and pre-renovation monitoring process to obtain a first baseline, information on possible technology solution sets, calculation of potential improvements and related uncertainties, achievable performance results, economic impact up to the next renovation. Continuous monitoring whose results will constitute an improved baseline from which begin decision-making in further building renovation or building maintenance. Indeed, deep renovation is a building life cycle investment that has to start at the right moment according to the running conditions and performances. I will now introduce you all stages in detail. The core activity of the FORARenew deep renovation process is the facility management, as owner or facility manager checks the effective operation and performance of the building. In case of problems not easily solvable, the detailed FORARenew energy audit protocol provides support for the collection of the proper information and to understand if a simple maintenance or a deep renovation is needed. In case of intervention need, the audit provides the drivers for deep renovation, identifying the main needs and deficiencies. The audit also collects building owners' needs and requirements that becomes the deep renovation drivers. To support the auditing phase as well as operational and maintenance one, the FORARenew answer is to gather, organize and process building information, energy use and indoor environment data. The auditor goes on site to collect basic information on the status of the building as is, to be able to get an accurate baseline of the building's performance ahead of the deep renovation design. The amount of data that an auditor collects in this phase can easily become significantly large and difficult to manage. The FORARenew solution to this common issue is an auditing app, acting as a digital notebook for the auditor on site. Users can load the available technical drawings in the app and then add pins with photos and notes on the drawings to keep track of all their notes in context. After auditing, the decision process is supported by the Cost Effectiveness Rating System, a decision-making tool allowing to address the best deep renovation package, considering energy consumption, comfort, cost, timing, and environmental impact, as well as the level of risk and possible subsidies, with the aim to facilitate the investment of the owner. The FORARenew team developed sets of state-of-the-art renovation packages designed to optimize the investment for transforming energy-consuming home with energy saving up to 60% while enhancing indoor environmental quality. The FORARenew packages include key innovative solutions and standard products whose integration was optimized to ensure reliable and robust results of the deep renovation process. FORARenew technology packages include a prefab timber building facade integrating ventilation unit, energy production, and solar gain control components, tackling heat loss and condensation problems while contributing to energy balance and comfort. An hydronic module that can be monitored to optimize the demand for heating and cooling in conjunction with the integrated renewables in order to provide a match between thermal energy demand and production. A smart ceiling fan that automatically adapts its speed depending on indoor and outdoor environment conditions. A tool for optimal harvesting of renewable source to produce energy to cover demand profile. These packages are modular and industrialized products, which means that on-site works can be meaningfully reduced while guaranteeing higher quality and performances. To give you an example, it can take half of usual renovation time, which means that there is limited disturbance for residents who can stay home during the renovation works. It is important to notice that the renovation decision-making process is usually mainly driven by other factors than energy audit. For instance, the subsidies established for a particular technology, the minimum performance requirements to be achieved, and the technology commercial advertisement with poor technical information. However, the cost effectiveness of such commercially available solutions is usually founded on basic models and generic considerations that often bring to very uncertain savings, leading to a gap in the performance prediction. For this reason, collection of monitoring data both for the pre-renovation state of the building and the post-renovation performance is another important aspect. Data can be used in the dynamic modeling of the deep renovation project for two main things. The first is to ensure that the virtual behavior of the building is properly calibrated and it is as much accurate as possible. And the second is to evaluate the efficacy of the renovation once completed. Monitoring data can be displayed through custom dashboards to the users. In this way, it can be said that the 4RNU approach transforms data in information and knowledge for the stakeholders in the renovation value chain.